So today we are going to see the Simulink parameter in MATLAB. So it is used to store, share, and configure the parameter values. So use of a Simulink parameter object. We are going to create a Simulink parameter object here in the MATLAB. So it is generally used to share a value among the multiple block parameters. Means, suppose in our model there are multiple blocks are going to be used, and we have to set a same value for the multiple blocks. So by using a parameter, we can assign the value for the blocks or whatever the parameters to be used in the blocks. Okay. And we can share a value among the multiple blocks. Okay. So again, the second point is easy to change the value. So by using this parameterization or the Simulink parameter, so we can easily change the value. If suppose there are too many blocks present in the model using the same parameter, and if we want to change the values of this parameter, so we have to go for each and every, we have to go in each and every block and we have to change the values. So instead of that, using the Simulink parameter, we can change the value of all the parameters of all the blocks at a single time by changing the parameter values. Okay. So and it represents an engineering constant or a tunable calibration parameter and a separate parameter value from its data type and other properties. And this Simulink parameter is used for configure the parameter data for code generation. So what type of the values are used to set in the parameters? So numerical, we can use the numerical value. Then we can use the Boolean value, ones and zeros. So we can use the instance of enumerated type. We can use the structure. It's the combination of the different data type elements here. So we can use the scalar or array. And also we can set any mathematical expression. Suppose we want to set the volume of a sphere. So the different variables, so the different parameters included in the expression, these are nothing but the radius. And then we are using the pi value. So by creating the parameters for a particular uh, value or a particular variable, we can set a mathematical expression over here using the Simulink parameter, and we can use that expression in our modeling. Okay. So next, creating a Simulink parameter, there are different ways to create the Simulink parameter. The first way, directly from the block diagram dialog box or the property inspector, we can set the parameter. So by using the model data editor, this is the second type. So we can have this method by inspect the parameters tab, then right click the row that contain a variable, and from the context menu, select convert to parameter object. Third one is the by using the model explorer. And the last one is by using the Simulink parameter function, and which is described below. So here where the syntax is given here. First, we can create the Simulink parameter. We can give the name to the Simulink parameter. Suppose we want to set a gain of a block. So we can have the parameter name as amplification or amplification factor. So our amplification factor is equal to Simulink parameter like this. And the next line Simulink parameter in bracket param value. Whatever the value we want to assign to this particular parameter, that value is mentioned here. That means if suppose the amplification factor we have to set as a 10, so in the bracket we can mention the value as a 10. Okay, that means the param object, the parameter Simulink parameter returns a Simulink parameter object with the default property values. And Simulink parameter, that is a param value, returns a Simulink parameter object and initialize the value property to the param value. So by this first line, we are going to set the parameter, and by using the second line, we are going to set a value to a particular parameter. Now, today we are going to see creating the Simulink dot parameter by using the Model Explorer. Okay. So we'll see how to set the parameter. So here, suppose we are having the block that is the gain. Okay. So I will explain you the simple way how we are setting the gain. Suppose we are using the gain as a 10. Okay. So we'll give some constant input. Suppose I set the value as a 2. I will use the display to see whatever the amplification factor. I will run the circuit. Okay. So that means input is 2. I have set the gain as a 10. So output is equals to 20. So we'll see how to set the parameter over here. Suppose again, here I'm using the same thing, gain. Okay. Or instead of that, I will just copy paste this one. I will use the same thing, same model. So I will just show you how we are using the parameterization. Now, we are using the Simulink dot parameter. So we are using the modeling. In modeling, there's the option Model Explorer. So click on that. So you will open this window. So here, I'm getting this untitled. Now I have not set any name to my file. So untitled. There are two options present here, the model workspace and the base workspace. In both of this workspace, we can set the parameter. But what is the advantage and disadvantage in the base workspace? Whenever we are going to create a parameter in base workspace, it will be available for any model, any block, any constants over there. But what is the disadvantage of this base workspace? Whatever we are going to create a parameter in the base workspace, that will only temporarily saved, or that will only temporarily available. Whenever we will close this MATLAB, so this will vanish. So we'll not be able to access whatever the parameters we have saved in the base workspace. But instead of this model workspace, this is the permanent store space or the method available over here. But disadvantage of this is that for which model we are going to set this particular parameter, the parameter is only accessible for that particular model only. So we cannot access that parameter saved in the model workspace for any another model. Okay, so this is the advantages and the disadvantages. I will show you that in the model workspace how to store this parameter or add or create the parameter. So by clicking the model workspace here, this options you can go in the add. There are the different options just like the MATLAB variable, Simulink parameter. Now we are going to see the Simulink parameter. You can click here or directly this is for MATLAB variable and this is for Simulink parameter. So directly I can click here. This will give the Simulink parameter. Okay. So it has added one param. So we have to give the name for this parameter. So suppose I will give the amplification factor. Okay. Or AMPF. Okay. So now we can have this the name we have given to the parameter, that's AMPF. So then again, this value, whatever we want to give the value, we can assign the value here, or you can assign the value over here also. So by giving the value here 10, suppose for previous example, we have seen we have set the gain factor as a 10. So here we will use, see, okay, so this gain factor we have set to 10. So I will give the value for this particular AMPF as a 10 and say apply here. Okay, that means I have created one parameter with the name AMPF and with its value 10. So again, there are different points over here. We can set the data type of the particular parameter, whatever we are going to use here. We can set the dimensions of here. So we can set the minimum, maximum value, the unit, whatever is there. So in this way, we can set the parameters. So now we will see how this parameter is going to be used in our model. So now here, this is the gain block. Okay, so in the first case, this directly I'm using the gain factor as a 10, but whatever the parameter I have set, I have to use that parameter. So here I will give the name of whatever the factor we have set. So this will show you the whatever the list of the parameters that are uh, present in the model workspace or present over here or added. So I have added the one parameter AMPF, and that is the source is the model workspace with its value 10. So we can select that one and you will see. Okay. Okay. So now here it has been added the parameter over here. Whatever we have set the parameter in the model workspace that has been added here. So I will simulate this model so that we can see whether we are getting the same results or not. Because for this AMPF factor, I have set the value is equal to 10 and the same thing without any parameter, the gain factor has been put as 10. So let us see whether we are getting the same result or not. That means we are getting the same results. So the amplification factor of a 10 has been added by using a set parameter. So it is, we have added the parameter over here. So giving the same results. So now, how we can say that it is used for the multiple blocks. So I will show you how we can use this for the multiple blocks. Okay, suppose we are having the multiple blocks present over here, and these multiple blocks are going to use the same thing or the uh, same value. Okay. Okay. And in this case, suppose the same thing, same count we will have. So again, we'll connect this to the same input. Okay. Okay. So now if suppose we want to change this gain factor of the block, so if suppose I want to make it 20, so I have to go in each and every block, then click here, then go to the third block, make the changes, go in the fourth block, make the changes and save it. So I have to go for each and every block and I have to make the changes. So instead of that, now see, we'll see this case here, MPF, whatever the parameterization we have used. So I will make the changes over here in the parameter. I will change the value is equals to 20. Okay. So the value has been changed now. See whether we will get the same thing. See, so it has automatically changed whatever the value for this AMPF. So because the same results we are getting, previously we were getting 2 into 10, that is a 20, but the gain factor, that is amplification factor, has been changed as a 20. 20 into 2, that is becomes a 40 here. So that means this is one of the advantageous thing of the parameter, that whenever you want to change the value of a parameter or any value being used in the multiple blocks, instead of going to the that particular block and changing the value, if suppose we are going to use the parameter and we can change, if we change the parameter value, so automatically that will reflect in changing the value of each and every amplifiers or each and every block's value. Okay, so in this way, we are going to use the Simulink dot parameters. That means by using the creating the parameters, we can store the parameters, we can share the value in the multiple blocks, and we can configure this parameter for code generation. And it becomes easiest way to change the value of a multiple blocks. So these are the advantageous thing of the Simulink dot parameter. Okay, thank you very much.